My name is Stafford Sheehan. I'm the Chief Technology Officer of Air Company. Thank you very much to the organizers for having me here for this event. And, I'm going to tell you guys a little bit about what we do at Air Company and kind of what the goals of our company is and what we are. You may have seen some of our consumer products, around like spirits, sanitizers, and fragrance. And we have a lot more that are coming down the pipeline too. So excited to tell you guys about Air Company today. So Air Company has developed technology that transforms carbon dioxide into carbon negative products. So that means we take carbon dioxide out of the air, we use it as a feedstock, as an actual reagent to create the chemicals that we produce. And we do that in a way that's environmentally responsible using renewable electricity so that our end products are net negative. They're net negative carbon dioxide. So they consume carbon dioxide from the atmosphere rather than generate carbon dioxide that goes into the atmosphere over the course of their production. Now, why do we do something like this? It seems like we're trying to fight thermodynamics, and that's usually pretty tough to do. But the reason why we do what we do is to fight climate change. Climate change is the greatest challenge that our planet's facing, and the primary culprit of climate change is rising atmospheric carbon dioxide levels, because that's the most abundant anthropogenic greenhouse gas. Water is also a very abundant greenhouse gas, but that's more part of the natural cycle. Carbon dioxide is the greenhouse gas that we're adding to the atmosphere in a way that is not part of the natural atmospheric cycles. The solution that we have is a system and systems that use carbon dioxide, as I mentioned, as a reagent to make different products. And we're going to talk about which products in a few slides. But we've achieved industrial scale recently. Recently, we deployed a ton per day system that operated at a natural gas-fired power plant. We plan to further engineer our technology over the next 3 to 5 years. 1 ton per day is great, but it's not the scale that we need to really address the problem. We need to be on millions of tons per day, at least, because the scope of the problem, the amount of carbon dioxide that we emit is on the scale of billions of tons. So in order to reach those billions of tons, we're going to spend the next 3 to 5 years scaling our technology up. And once we achieve world scale, then we're going to be able to sell our alcohols and fuels in these commodity markets where we're able to displace fossil fuels. So as a carbon dioxide utilization company, we have an additional benefit to our technology. We not only take carbon dioxide out of the atmosphere, but we use that carbon dioxide to create products that are currently made using fossil fuels. So our products not only use carbon dioxide as a reagent, but they also reduce the need to drill for fossil fuels. And drilling for fossil fuels is the problem right now. It's the reason why we have all this carbon dioxide in the atmosphere. So how are we going to do that, and how are we going to get there? There have been a lot of third-party analyses about the total scope of carbon dioxide utilization technologies like ours that produce chemicals. And if the world's industries utilize Air Company's technology, we could reduce global emissions by 10.8%. That number may not sound like a lot, but it's actually billions and billions of tons of carbon dioxide in the atmosphere. It's a huge impact. It's the largest impact that an individual technology could really have. That just stresses the scope of the problem. If we can tackle 10% of global carbon dioxide emissions, there's got to be a lot of other people that are working with us to address the other 90% too. We are going to be part of a portfolio of solutions, part of many solutions that are going to contribute toward addressing our climate change problem. And the way that we're doing that is we're making 3 main chemicals: ethanol, methanol, and aviation fuel. Because the total scope and the total CO2 emissions of their production are the highest of all the markets that we've looked at, and they're the chemicals that our systems are optimized to produce. So we can produce these 3 chemicals out of our system. We've demonstrated this on this ton per day of CO2 utilized scale. How does our technology work? So we start with renewable electricity. Renewable electricity is captured using solar photovoltaics and wind energy. I'll talk a little bit more about that in the coming slides. Our carbon dioxide is source agnostic, so we can get the carbon dioxide from anywhere, We've sourced it from biogenic sources primarily. So we actually get our carbon dioxide from legacy ethanol production from fermentation. We can also use carbon dioxide that's pulled from natural gas power plants or pulled from the air. And then we use some of that renewable electricity to power a water electrolyzer. What that does is that splits water, H2O, into hydrogen gas, which is H2, and oxygen gas, which is O2. The oxygen gas is emitted, and that's our only emission out of this whole process. Our only byproduct is oxygen, kind of like a tree, like a plant. And the hydrogen gas is fed into a multitubular reactor that is our patented reactor design that contains a proprietary catalyst that's sitting inside it. That's what we make in-house. That's what we make in our laboratories. And what that catalyst does is that takes the carbon dioxide and it takes the hydrogen, mixes them together in just the right way to make those alcohols or to make those fuels. Distillation system downstream from that allows us to separate them. And so that's how we get the ethanol that you can see is used in our consumer products. Then downstream from that, we can further upgrade the alcohols to produce additional jet fuel. So what do we do right now with this technology? So the three products that you see on the left there, spirits, Air Company's vodka, household cleaners such as Air Company's Air Spray, which is our hand sanitizer product, and fragrances, which was our third product that was launched in October of 2021. Those are the three products that we currently have in market. We use the ethanol product that's made during our research and development to make those products. So we're doing R&D on these systems, and the byproduct of our research is that we make a good amount of liquid. The byproduct of our liquid, the byproduct of this liquid production is that we're able to make products in the near term. So we're the first carbon dioxide utilization company to really have a variety of products in market with Air Company's vodka, Air Company's hand sanitizer, and our air perfume, our air fragrance. As we scale our technology, we want to go toward more commodity markets, though, like commodity ethanol, commodity methanol, and commodity aviation fuel. And so we're using these consumer products as essentially a proof of concept of our technology. You can imagine that if you buy one of Air Company's products, be it hand sanitizer, fragrance, or spirits, it's not like you're just buying the product. You're investing in the research and development that gets us to those larger markets and that 10% of global carbon dioxide reduced. So what do we make our consumer goods and eventually our commodity goods out of? We make them out of carbon dioxide, water, and renewable electricity. So the carbon dioxide is currently we source it from biogenic sources. So that means that it was carbon dioxide that was captured as a plant and it's going to be re-emitted. But before it gets re-emitted, we capture it and we take it. We've also tested several different technologies, including things like direct air capture. Our water is fed into the electrolyzer. You can see that photo of me standing in front of it in the middle of the slide. In that electrolyzer, there's a stack that has platinum and iridium catalysts sitting in it. And what those catalysts do is they use electricity to split the water into hydrogen and oxygen gas. And so it's called green hydrogen because we use renewable energy to power that. On the right, we source our renewable electricity. Typically, it's a combination of wind and solar electricity. It depends on what the grid's demands are at the time. And we work with a company called Clean Choice Energy for that. So these are our raw material. This is everything that goes into our process. And so there's no other harmful raw materials, really. It's just we're taking the carbon dioxide out of the air. We're taking water and we're using that to produce hydrogen. We're using the hydrogen from the water, and we're using renewable electricity to power the whole process. At Air Company, we operate 3 facilities currently. We have a catalyst production lab that's in New Jersey that's making our catalysts, and that's the secret sauce that sits in our reactor and allows the carbon dioxide to transform into the different products that we make. Our pilot facility, which is you can see in the middle there, is reactor testing in New York. That is a 16-foot tall reactor. That's a large prototype system. And then our production facility, that's currently in Calgary, but being shipped down to New York at the moment. That's what we actually use to produce the quantities and the volumes of product that we make and sell. what happens in these facilities. Well, here's a couple of flow diagrams, and there's a paper that you can, if you want to learn more, write down the name of that paper that's at the bottom of the slide, Scaling CO2 Capture with Downstream Flow CO2 Conversion to Ethanol. And that actually goes into a lot more detail about what we do than I'm going to go into in this presentation. Very briefly, what we do at our pilot facility in New York, we source the CO2, as I mentioned, from biogenic sources. And then that's fed into a compressor together with the hydrogen that's produced by water electrolysis. Those gases are fed into our flow reactor, and that makes a crude liquid. That liquid's distilled, and we remove the methanol in this case. So we're not using the methanol for in our New York facility. We remove the methanol, and we just take the ethanol. We mix that together with either water or fragrance for the perfume, or a couple of the other compounds that are used in the hand sanitizer, like glycerin and hydrogen peroxide, and then we bottle them. Our production facility, it's the one that's moving from Calgary to New York. That system captured carbon dioxide from a natural gas-fired power plant. So the CO2 would be emitted by the plant. Before it would get into the atmosphere, we'd capture it. We'd put that into a compressor together with hydrogen, and then we'd feed that into our flow reactor, and we'd get a crude liquid out of there that we would then distill and turn into consumer goods in New York City in our pilot facility. So what we achieved with that production facility was really de-risking our technology and showing that it can be scaled to the really large scales that need to be implemented to be able to fight climate change. One of the biggest accomplishments that we had over the course of the last year was that we achieved over 5,000 continuous operating hours on the system, and that really just shows that it's stable enough to be able to scale up. With that 5,000 continuous operational hours achieved, now we can go on and build the larger ones that really can have a big impact toward fighting climate change, which I have a little preview of on this slide. So these larger systems are 510,000 times the scale of that system you saw on the last slide, the one that sits on the back of an 18-wheeler. And these systems are the ones that are going to truly drive carbon dioxide sequestration to generate commodities that can be used for things like aviation, that can be used as a feedstock for chemical processes. So on the right, you can see that we're going to be able to utilize around 10,000 tons per day of carbon dioxide. Those are the scale of systems that you really need to be able to turn the dial on climate change. And even larger than that. So that's system 4.0, but we've already predicted going out to things as large as a 6.0. That's a truly world scale system that can create these products on the scales to be able to fulfill all the industries that burn different fuels and use different chemical feedstocks around the planet. At Air Company, we've been really fortunate to be able to win a handful of awards from the United Nations. We were the top prize winner at NASA's carbon dioxide conversion competition, and we were honored to be able to receive that and to be able to work with them. We were a finalist in the Carbon X Prize. That's the Carbon X Prize is what was staged at the natural gas-fired power plant where we deployed our primary system. We were Time Magazine's Invention of the Year in 2020, and in 2020, Fast Company also named us one of their most innovative companies on the planet. So, and we've won several other awards, including gold medals in the three largest spirits competitions, the three largest blind taste test spirits competitions on the planet for our vodka. So one of the most important things about our entire production process is that we're not only making products from carbon dioxide, we're making very premium products. We're making products that are not just better, not just better for the planet, but they're also better than the alternative that you can buy that's made out of fossil fuels. For our vodka, that was proven out in blind taste tests. So the people that were tasting it didn't even know that it was made from carbon dioxide. We also work together. None of this would be possible alone. So we work together with a lot of excellent partners. Linde for our sourcing our carbon dioxide, Nel Hydrogen for our water electrolyzers, Zeton is our EPC. So that means they're engineering, procurement, and construction company. They assist us with the engineering of our systems. We've worked with Draper Labs at MIT, National Renewable Energy Laboratory. We have a project together with them. We're in the GCXN program together with them. We were the recipient of an SBIR grant from the National Science Foundation, and it's been an honor to be able to work with them. And then NASA has been incredibly supportive of our company through their Centennial Challenges program, where we were one of the winners of phase one and the top prize winner of phase two of the carbon dioxide conversion competition. In our business, we have several different sustainability initiatives, and this is important beyond just the chemistry and the hard science, of running our reactors. Life cycle analyses, are what guide us in both our development and our packaging and everything that we do, as a business. So understanding the life cycle carbon intensity of different components of what we do. That means, we analyze everything from the capture of the carbon dioxide, whether it's from air or from a biogenic source, all the way through to the end of life of the product. You'll see on some of on our spirits bottles, they say, peel the label and reuse it to give it a second life. And we try to use everything in our entire production process is recyclable. Our LEED certification, facilities that operate using renewable energy, and then ongoing different verification procedures are really important as well, just to make sure that everything across the value chain is being done in a way that is responsible for the environment. And then lastly, we also, this of course wouldn't be possible, to fight climate change and to try to, remove this massive quantity of carbon dioxide from the air without an entire ecosystem of companies that are doing a lot of great things. So we're the only people that have CO2 derived consumer products in market currently. And that's partially because of our unique approach. But there are a lot of excellent companies that are doing work on CO2 derived fuels. This is such a massive problem. This requires such a Herculean effort that it's something that we need all of these people. We need, not only air company alone cannot solve the entire climate change problem. So we need all the people that are on this slide to be able to contribute as well. On the right, you can see companies that produce CO2 derived building materials, and that's another way of sequestering carbon dioxide into things like concrete, or bricks. With this as the kind of abridged ecosystem, there are several other excellent companies that are not even mentioned out here in the CO2 utilization space. Hopefully all of us together are able to do that. I would say the planet depends on it. And then lastly, at the very end, really appreciate you for inviting me here and for having me here for this talk. Honored to have been invited to give a keynote. Thank you again to the organizers. And if you have any questions, please feel free to email me. And that's a wrap.